Welcome back to part 2, class. Now let's take a look at question number 2. What angle between forces produces a resultant with the greatest magnitude? And then which one produces the smallest magnitude, or smallest resultant? So, let's take a look. We look up here. We can just look at this first column, and you'll notice which number of these three numbers is largest. And you should get the hint that that's going to be 0 degrees. And it should do the same thing for these columns as well, and you'll notice that hopefully. And then you should notice which one gives you the smallest one. And these are your resultants right here, guys. And that's going to be this row right here. So, 180 degrees is going to be the subtraction of vectors and will always give you a very small value. And 0 degrees is basically the scalar addition of vectors, regular addition like you have grown up with. So that one's going to give you the largest possible vector resultant. So let's move on to question 3. Question 3 says draw the following vector and use trigonometry to find a x, a y, horizontal and vertical components, and use 4 centimeters at 35 degrees. Let's go back and look at this. When you think horizontal, you should immediately conclude that I'm talking about the x. And when you see vertical, you should think I'm talking about the y. Now, these could be scary to you, and I understand. Subscripts were very scary to me when I was young. Now, ax is the same thing as the big X that Mr. Lee gave you in the formulas the other day. So the other day, Mr. Lee wrote a formula x equals h cos theta, where theta is your angle. Whoop, I'm missing an S. Sorry. Friday night, getting late. So, theta is the angle of your vector with respect to the x-axis. Very important. I'm going to stress that again. Theta is your angle with respect to the x-axis. Cos is a trig function you guys should be familiar with. And then last but not least, h is the hypotenuse of the triangle that you would draw. And the x component will tell you when you draw this vector, and I guess I'll get around to drawing a vector for you guys. Let's make it blue. So this vector is going to come out like this. And accompanying this vector, I'll make your x and y-axis. And I'll just move these in a second and make them where I want them to be. Now, so here we go. We've got everything Mr. Shaw has ever dreamt of. Now, let's talk about this. This angle right here is your theta. Oh, come on, don't do that. This is your theta. And it's always, always, always with respect to the x-axis. Never make it with respect to the y. So it's always got to start here and measure around. Even if it's over here, you just keep going around counterclockwise until you reach your vector. And that's how it has to be. And that's just the system we use, guys, and you'll find out later why it's so critical. So, back to the lecture though. On your reference table though, you'll come across a different notation of this. And that's going to be using the ax equals a cos theta. And you may say, wow, that's much different, and you may be terrified of it. But it's not bad, guys. Basically, the a stands for any vector, and the a sub x is the x component of any vector. So when you use this formula, what you're going to do is you're going to find this x component. Now, once again, both of them are the exact same. Don't do that. Both of them are the same. They will tell you the x component that is at the very end of this. Remember, the vector is defined by 2 points. This end down here with the head, and this end down here with the tail. And the tail should be at the origin. It's not because I keep moving the line. And you're going to use these formulas, these two, or actually this one, and you're going to use the other one. I'll write it in both styles again. Sorry, I meant to go y. Y equals h sine theta, or once again on your reference table you'll find it as ay equals a sine theta. And one of these two formulas is going to get you your y component up here. Now guys, please, please, please take time and do this. The calculations are important. Let's go down and take a look at the very last one. It says, draw a force so its vertical component is its maximum possible value. Now change the angle so that it has the largest possible horizontal value. So let's take a look at some forces. And I'm going to draw my x and y axes first. So there's my x and y axes. Now, the thing you should realize is that when you have a vector, like this one right here, or this one right here, or this one right here. Now, sorry, they're not meeting at the origin. It's kind of difficult. Once again, I've probably said before and you caught it. Or this one right here. What you'll see is this. You've got a series of vectors here. Now, what you would want to do is they should all be the same length. Like make it easy, like 10. And what you would want to do is pick some angles. So let's pick some angles for ourselves right here. Let's pick an angle to be 10 degrees. Let's make this 45 degrees. And let's make this one 70 degrees up. I don't want to move it. Sorry. And then let's make this last one 80 degrees. I know they're not to scale, guys. You can yell at me later. I'm not giving you any points. So, now, if you plug these into these two formulas from the previous problem, what you'll see is you'll start getting the x components and the y components for your points. Now you may say, Mr. Shaw, this is a long, tedious process, I know, but what you'll see is as you go up in angles, the y value should go up. Do you guys see that? This tip of this last vector is much higher than the tip of the original one. The y value goes up, but what happens to the x value? Well, the x value, this is your x-axis, remember guys, and this is your y. So your x value, as the angle goes up, which one was here, oh come on, once was here, then went to here, then went to here, and finally ended up there. So you should see that as the angle increases, your x component should go down, while your y value, once again, started here, goes up a little bit higher, and I'm just matching it up over here. It goes up higher still, and then higher still. Not very scientific drawing, or not very precise drawing, but you should see that as your angle goes up, the y value goes up, and your x value should go down. Now, if you've guessed what happens when you reach 90, you should actually see the trend do something interesting, and I'll leave you guys to look that up on your own. Okay, last question. I can do it. So we're going over to the next page, and it says, when the angles make a vector, when the angle a vector makes from the horizontal increases its horizontal force. So this is what I just talked about, guys. This horizontal force, it's a little rough wording. I know this paper needs to get edited. I want you to find your x component. Is what I'm really trying to get to. So I cannot spell tonight. So I want you to find your x component. What happens to your x component as the angle increases, and what happens to your vertical component? And I just talked about that. That was exactly what the previous problem asked you as well. So this is kind of the previous problem written differently, but again, poorly written, I understand. Okay guys, thanks for listening.